Here's a technique called partial quotients. Our problem, 6 goes into 8. Yes, it does, one time. But our 1, we're taking 6 into 8, that would make it 1,000 that we would need because 6 went into the 8,000 position. So we're going to do 1,000, multiply 1,000 times 6, and we're going to get 6,000, and subtract our total, our difference, I should say. Difference is the answer to a subtraction problem. 6 from 8 is 2. So we have 2,324. In this case, our next pick, 6 goes into 2. That's too small. How about 23? 6 times what will get us close to 23 without going over it? Well, 6 times 3 is 18. 6 times 4 is 24, which is over. So it's 18, that's 3, but the 23 now is in the hundredths position. There's 2 numbers after it, so we would have 300 here. 300 times 6 are 2 zeros, and then 3 times 6 is 18, and subtract. 4, 2, here we're going to have to regroup. 13 is, take away 8 is 5. Will 6 go into 5? No, it's too small. We're going to move over. 6 times what gets us close to 52 without going over it? Well, 6 times 8 is 48, but we have one number after the 52, so we're going to need a 0. It's really 80 that we're saying. So our multiplication would be 8 times, 0 times 6 is 0, and 8 times 6 is 48. Subtract. 12 take away 8 is 4. 6 goes into 4, nope, 44. What times 6 is close to 44 without going over it? Well, 7. We did the whole number 44, so there is no 0 after it because we used up the whole number. 7 times 6 is 42. Subtract, we get a 2. That's smaller now than the 6, so this is our remainder. And the partial products over here, partial quotients, are adding all of these numbers up. Now, I did not keep my columns as straight as I could have. I guess I just pushed that one in there. And here we're getting a little crooked. So even I can do it with being crooked there. 7, 0 and 0 and 8, 3, and 1. You can see that it was a little bit crazy because I didn't quite keep my columns lined up very well. So the answer to this was 1387, remainder 2. And note to self, next time I'll line my columns up better.